Hi everyone, welcome back to another video on Oxbridge and Imperial Engineering, STEM, Natural Sciences, Physics and Mathematics interview question practice. Today we're going to go through a geometry problem step by step without knowing the answers to start with or the solutions to start with. So let's get started. So this question, let's read this question. There's a field of radius A with its center at point O. A goat is tethered at point T there, on a rope of length R. It is required, so this is the goat here. Oh, this is not the goat. Wait a minute. The goat. Greatest of all time. Goat. So the goat is, I think, along the arc there. It is required that R is the correct length so that the goat can eat half of the grass in the field, i.e. the sum of all the shaded areas must equal half of the overall area of the circle. The angle theta is defined as shown in the diagram. Start by satisfying yourself that sine of theta over 2 is equal to R over 2A. So let's think about how this equation is derived. Sine of theta over 2 is equal to R divided by 2A. Well, what we know here is obviously we can apply the cosine rule, but there might be... Oh yeah, okay. So essentially what you can do is divide the triangle into half so that the angle here is theta over 2 and the side here is R over 2. So what you get is sine of theta over 2 would be equal to R over 2 divided by A, so R over 2A. Then derive an expression for the shaded area in terms of theta and R over A. Substitute for R over A to get an equal equation only in theta. Then plug the values given below into your equation to determine which one represents the correct solution to the problem. So the next step that we have to do is derive an expression for the shaded area in terms of theta and R over A. So the shaded area here can be derived in a way. Okay, you can definitely derive it. So it says it is required that R is the correct length so that the goat can eat exactly half of the grass. Okay, so let's think about how you can derive the area of the shaded area. So essentially, there are two ways. You first need to find out the area of this arc. Wait a minute. Hold on. The area of this arc here. Here. And to find that, what we need to do is find the angle here. That's very important. We know that this is theta over 2. This angle must be 90 degrees minus theta over 2. And so the angle in total would have to be 2 times 90 degrees minus theta over 2, which is 180 degrees minus theta. So that is the angle here. So the area of this arc here, so the area of this arc T like this is equal to half of 100. Oh, this must be in radians actually. So pi minus theta. So half pi minus theta r squared. And now we're left the job of working out the green shaded areas. So this area here is equal to, let's rub it out. So area of this is equal to would be half of theta a squared minus the area of the pink triangle, which is equal to half of a squared sine theta. So 2 times that area would have to be equal to a squared times theta minus sine theta. So the total area, expression for shaded area, total shaded area would have to be equal to half pi minus theta r squared plus a squared times theta minus sine theta. And it says derive an expression for the shaded area in terms of theta and r over a. Well, I didn't get r over a. It says, okay, substitute for r over a to get an equation only in theta. So now it's going to be only in theta. It says plug the values given below into your equation to determine which one represents the correct solution to the problem. So I'm going to have a look at some answer choices, and apparently we have to work out what theta is going to be, or what r over a is going to be. And we know that this shaded area must be equal to half. So the consequence of that is when you multiply both sides by half, you get pi minus theta times r squared plus 2a squared theta minus sine theta equaling to 1. So essentially that's what you would get in this circumstance. And we should try to use the information of sine theta over 2 is equal to r over 2a, information there, because it's going to be quite necessary for us to perform calculations based on that. Okay, so I guess this equation is not that useful if you don't have r over a or sine of theta over 2 in this equation. So let's derive it again. So let's then derive an expression for the shaded area in terms of theta and r over a. So you want r over a in this equation. You want that into the equation. So what you have to try to do here is okay, so you have that equation. Yeah, okay, so how am I gonna get the answer actually? Because we don't know. Oh well, Another relation we have is sine of theta over 2 is equal to r over 2a. So this really brings about an equation out, really tells us something. So perhaps one of the ways to solving this problem could be to, substitute r out. So r would be equal to 2a sine to r squared would therefore be 4a squared sine squared of theta over 2. That's what r squared would be like. So we've got to eliminate r, and here we have 4a squared of sine squared theta over 2 times pi minus theta, and then plus 2a squared theta minus sine of theta is equal to 1. This doesn't help us, does it? No, I don't think it helps us. So perhaps I have to have a look at the hints to this problem. Okay, so essentially, yeah. So what I have here is, half of pi minus theta times r squared, yes, minus that. Yeah, so half of pi minus theta r squared plus a squared sine theta, minus, yeah, that makes sense. That all makes sense. This here does make sense. Then okay, so pi, I'm looking at the answers here. So where do we actually have pi a squared theta over 2 pi? So half theta a squared, plus quarter, pi minus theta, a quarter of that, r squared, we do have that, and minus, first, okay, so we do have everything, do have everything in this equation here, and that's equal to what? Equal to a half, so okay, so you have this equation here, and what's necessary is, okay, you divide by alpha, okay, 2. So we have this equation here times by 2, get this equation here, and I think we should be able to solve the problem by now. But let's just move things down a little bit and have a look. So we have this, right? What we want to do is divide both sides, I guess, by a squared. So pi minus theta times r squared by a squared plus 2 theta minus 2 sine theta is equal to, in fact, this, oh, I see where I went wrong. This value should not be half, but instead half pi a squared. That's where I went wrong. It says, because the area says half the grass in the field. It doesn't say half, it's half the grass, so it's half pi a squared. So this becomes, this is pi a squared, so this is equal to pi. And so what you would get is essentially, to substitute for r over a to get an equation only in terms of area. So we know that r over a from earlier is equal to 2 sine of theta over 2. So therefore you get the equation pi minus theta times 4 sine squared theta over 2 plus 2 theta minus 2 sine theta is equal to pi. And if we plug that into our calculators, I'm just going to use a graphical display calculator, go into maths numerical solver. We get the first equation as pi minus x, pi minus theta, times 4 times sine of x theta over 2 squared plus 2 theta minus 2 sine of theta, and the value here is second is equal to pi. So solving it, we get theta is approximately equal to 2.18, which is incredibly close to the number e for some reason. I'm starting to wonder what's going on. Okay, so r over a, what's r over a? R over a is equal to 2 times sine of that value. So r over a is 2 times sine of theta over 2, say theta over 2, and that's about 1.77, which is about 1.77, and does not match with any of the answers we were given. And I'm not sure about the situation here. 1.77 is not an answer, unfortunately. Okay, just 2 times sine of theta over 2. Let's have a look at the numerical solver again. Just have a look. So pi minus theta times 4 times sine squared of theta over 2 plus 2x minus 2 times sine of x, and this is equal to pi. Oh, I see. It's not equal to 2.18, but rather it's 1.236. And if we plug that value again into our calculators, we get r over is about 1.15887, which corresponds to D. And I think that's the correct answer.